Okay guys, it's me Imad. So today in this video tutorial we will learn about how to interface or how to simulate a servo motor with the PIC microcontroller. The simulator which we are using is the simulide 1.1.0. So how we can do that? First of all, we have to search for our microcontroller. So we can drag it down, and here we got the PIC series microcontroller. So click on pic16f. And here we got our pic16f877. So click on it and drag it out. Also click on zoom to fit so that we can see it properly. So this is our microcontroller. And in order to make this microcontroller enable, we have to take a fixed voltage power supply, so that we can supply a 1 or plus 5 volt on the MCLR pin, which is actually enable pin of this microcontroller. Okay, so now the enable is applied, 5 volt has been given to this pin, so our microcontroller is now on. Okay, now we have a lot of pins like port A, port B, port C, port D. Okay, so we can attach our servo motor to any of the pins, and we will write servo here, and we got our servo motor. Again click on it and drag it out like this. Again click on zoom to fit so that we can see these properly. Now servo motor has 3 pins: positive supply, ground and signal pin. The signal pin must be connected with that of B0 pin. You can use any other pin. If you want to change it in your code, you can use any other pin. It's not compulsory to always use this pin. Now take ground. Ground must be attached with that of ground pin of the servo motor, and V positive. We will copy and paste this power supply. Okay, and we can supply certain voltage on the, usually it is 5 volt operated. Okay, now our circuit part has been done. Now we will open our code, and we are doing coding in our micro C PIC Pro compiler. Okay, so let me open our micro C PIC Pro compiler. So this is our compiler. Now we can click on new project and next, and here we write servo underscore 000, name of the project. You can write any other name. Then pic16f877, yes, it is the same as we have used. So click on next and finish. Now we got our void main function. So in void main function, obviously it will just execute for one time, so we will write while1. While1 is a forever loop, means that whatsoever we will write in the brackets of this while1, that is, this one is the starting bracket and this one is the ending bracket. So whatsoever we will write in these brackets will run again and again. Okay, and we will get a continuous running of our microcontroller, not a single time. So in while1, okay, let me see. Yes, in while1 we will write unsigned, or we can do one more thing. We can define a variable in void main. This is unsigned int a. Now what is this? A is actually a variable in which we can store certain unsigned integer data. Okay, unsigned and signed integers, you can you must know the difference between signed and unsigned. Okay, after we have declared the variable, and here I'm just telling you that you just take this variable a to store certain value. So in while1 we will again write for a is equal to 0, a is less than 50, and a plus plus. Why we are writing all this? Okay, why we are writing all this? Because we want to run this loop for 50 times. Simple as that with the help of this for loop, whatsoever will be inside these two brackets, it will run for about 50 times. And why we are doing all this? Because we want to make a PWM or pulse width modulated signal. So that is why we are just running it for 50 times. Okay, so here again we will write port P dot f0 is equal to 1. Now what is this? Now we are sending a logic 1 on the port B 0th pin, means that the first pin. F0 is the first pin of port B, which is actually B0. So in order to represent B0, we will write port B dot F0 is equal to 1. Okay, after we have sent the 1 on this, then we will write delay underscore microseconds. Now what is this? Why we have written this microsecond? Because we want to introduce a specific delay of 800 microseconds. Okay, I am explaining. Okay, after I have written all this, I will explain to you that why we have written all this. Let me copy it out and paste it out. Now, okay, this one. So here you can see that we have a total length of the signal, which is 20 milliseconds, and in microsecond it is 20,000 microseconds. Okay, so in 20,000 microseconds we have sent 1 for 800 microseconds and 0 for 19,200 microseconds. Means that signal is on for 800 microseconds and off for 19,200 microseconds. So it will give us a specific duty cycle. Duty cycle means that the on time of the cycle in which signal is at 1 or at logic 1. So it will produce a specific pulse width modulated signal, and with this time we will get a 0 value, that is 0 degrees for our servo motor. Okay, and after this has been done, we will write a delay of millisecond. Now we will introduce a delay of 2000 milliseconds. And after this has been done, we will go and we will write the next. Okay, let me write some comments for you. That is for 0 degree rotation. Now you can how you can get for every angle? You just need to change this on time for 0 degree rotation. Okay, you can change this on time and off time, but you must know that the total time that is on and off must not exceed 20,000 microseconds, like this. And now I will copy it out, Control C, and now this is for 90 degrees, for 90 degrees rotation. Okay, now I will write it like this. Again, the same thing. Okay, and for a is equal to 0, a is less than 50, a plus plus, and again all this. But for 90 degrees we have a very different value, which is 1518,000. 1518,500. 500. So this is for 90 degree. So now we will run it out, but before going, okay, we will write in wide main, we will write port B is equal to 0x00. Why we have written it out? Because we want to declare the port B as the output port or the output. Okay, we can declare it as input as well if you want, but here we are just declaring it as the output port. So now click on run servo 000. Okay, it's running. Okay, and then I will click here and then I will make a hex file here. Click on save, and here we will write servo underscore 555. So this is the name of our servo hex file, and hex file must be given to the PIC microcontroller so that it can work properly. It will be saved on the desktop, so click on save. Okay, so now we will open our what's called as the microcontroller section, and here we will servo 888. No, it is servo 555 hex, and now our some firmware has been successfully loaded. Now we will run it out. Okay, and one more thing, that we have to decrease the frequency to 8 megahertz. Wait for a while. So it is unsigned int a. Okay, sorry. Here we will write trace B, and it must not be port B, because with the help of trace command we can declare this trace B as the output. Now we can run it out, and like this and this. Click on save, and this thing. Now we will run it out. And one more thing, that we have to again go and we will again burn it out like this. So now you can see that our servo motor is going at 0 degrees and then to 90. And if you want to achieve certain other angle, we can change its delay microsecond time period, which on the other hand changes its duty cycle, and we can get our angle. We can get our desired angle. So hopefully you got the concept that how you can use the servo motor with the help of PIC microcontroller in the simulide simulator. So thanks for visiting our channel, and don't forget to subscribe.